Well, we're in the viewing area here. You can see the vertical assembly building. We'll just pan around, see some of the launch pads. This is the viewing stand for the public, the closest that the public can be to any of the launch pads. Mostly water. You can see a lot of water here. There's the tower, shuttle tower. Some private launch pads and the buildings. The new SpaceX program.
The one to the right.
This is pad 39B. This is being transitioned for the new space system. Those blinking lights are lightning arresters. And this is the main pad 39A. Most of the shuttles and some of the Apollos were shot from this pad. This is 39A. All the Apollo and many of the shuttles came from this pad. This is 39B. Was used for shuttles and it's being transitioned now for the new space system. This is the vertical assembly building. It was the largest building in the world. It's where the shuttle and the rockets are put together before they roll out to the pad. This is a vertical assembly building. It was the largest building in the world, where the rockets and the shuttle are assembled before the rollout to the pad.
When I was a kid, I used to dream about flying through space. Every week on TV, I'd watch my heroes as they jumped into their rocket ships and took to the stars. And I wanted to be like them. They had courage, imagination, and no problem ever stood in their way for long. You know, in the end, when we actually did send men into space, it turned out that those were exactly the qualities it took.
I'm John Hudson. This is Pad 39 of the Kennedy Space Center. I was a launch controller here when from this very spot, man took off to fly to the moon. It was a journey that began 12 years before that rocket ever left the ground. And it started on the other side of the world.
Back then, we were one of two superpowers that always seemed to be on the edge of a terrible war. In 1957, the Soviet Union launched the first ever man-made satellite into Earth orbit. They called it Sputnik, which means traveling companion. And in a world where peace hung in a delicate balance, it seemed to create a dangerous advantage. Every ham radio operator in America could hear it beeping. People were afraid. Were the Soviets looking down on us? Watching us? If they could make a satellite pass over our cities, could they do the same with a bomb? Our own space program kicked into high gear, and less than 2 months later, we were ready to launch our own satellite. In 1961, we fell even further behind. Soviet cosmonaut Yuri Gagarin became the first man into space, circling the world in just 89 minutes. We had our own astronauts, and they were eager and ready to take the big ride. But our manned space program couldn't seem to get off the ground. We stuck with it, and on May 5th, 1961, things finally started going right. Astronaut Alan Shepard took his ship Freedom 7 6.5 miles into space. America had its first space hero. Just a few days later, our space program received a new challenge. But this one did not come from the Soviet Union. It came from our young president. In one inspiring moment, he changed the mission from one based in fear of the present to one of hope for the future.
But why, some say, the moon? Why choose this as our goal? And they may well ask, why climb the highest mountain? Why, 35 years ago, fly the Atlantic? Why does Rice play Texas? We choose to go to the moon. We choose to go to the moon. We choose to go to the moon in this decade and do the other things. Not because they are easy, but because they are hard.
We hadn't been more than 16 minutes into space, and now we were going to the moon. We would have to design a rocket the size of a 36-story office building, put it together with the precision of a microscope, and accelerate it to the speed of a bullet. Then we would have to guide it to a moving target 250,000 miles away. Many people thought it was an impossible dream, but 400,000 of us set about making that dream a reality. It would be the longest, most hazardous voyage that any man had dared to attempt. But step by step, mission by mission, we orbited the Earth, perfecting the skills and technologies we would need on this incredible journey. Our astronauts practiced maneuvering, docking, and the 1,000 other tasks that would comprise the moon mission. We created new alloys, lighter and stronger than anything seen before. We designed communication systems that would be reliable over the vast distances. And behind it all, we tried to perfect the rocket that would be powerful enough to punch out of Earth orbit and take us to the moon. One day, however, the dream of flying to the moon almost slipped away. It was January 27th, 1967. Astronauts Virgil Gus Grissom, Edward White, and Roger Chaffee were on board Apollo 1 for a plugs-out test, a full-scale dress rehearsal for the actual launch. Suddenly it happened. There was a fire in the capsule. 3 men whose lives had been in our hands were lost.
Surely the opening vistas of space promise high costs and hardships, as well as high reward. But this country of the United States was not built by those who waited and rested and wished to look behind them.
After Apollo 1, some thought we'd failed, and that the moon was out of our reach. But we owed it to those men to learn from their sacrifice and to carry on. We started taking the Apollo vehicle apart, piece by piece. Was the design flawed? Had safety been compromised? Tough questions. And we spent 1.5 years redesigning the spacecraft so that no astronaut's life would ever be at risk because we overlooked something, or because we could have done something better. A moon rocket is 91% high explosive, and it goes into the most unforgiving, hazardous environment there is. We could never make it risk-free, and the men who flew them knew that. We didn't send men into space again until Apollo 7 orbited the Earth, testing some of the new designs. When everything worked perfectly, the decision was made. The next mission would travel to the moon. It was mankind's destiny to leave the shores of our planet behind and strike out across the vast ocean of space. In the great span of our history, now was the time that we could. now was the time that we would. We stood on the eve of the longest, most dangerous journey that any man had ever undertaken. And it would be taken by Frank Borman, James Lovell, and William Anders, the crew of Apollo 8. Through those doors, you'll find the firing room, launch control, just as it was on December 21st, 1968.
As you enter the firing room, please watch the staff use the...
This is the firing room for Apollo flight.
Good afternoon. Welcome to the firing room theater. If anyone needs to leave during this 10-minute presentation, please use the theater doors on your right. As a courtesy to others, we ask that there be no smoking in the building or flash photography during the show. Thank you.
Control for the Apollo missions. This is not a mock-up. These are the very consoles we sat at when men first took off to fly to the moon. The tragedy of Apollo 1 had put us a year and a half behind. We were making up for it in one big leap, and we were doing it with a rocket that no man had ever flown before. It was a few days before Christmas, 1968, when Apollo 8 sat on the pad. She was the first of a new kind, a moon rocket. This was the Phoenix, risen from the ashes of Apollo 1. The first Apollo crew did not die in vain. This was to be their testament. "36 stories high, she had been fully fueled throughout the night. The liquid oxygen in her tanks caused ice to form on the outside of the craft. The extreme temperature differences between the air and the sub-zero fuel caused the metal skin of the rocket to expand and contract. Everyone who was on the pad agreed. It was as though the rocket was alive, breathing, straining at the leash. Earlier in the morning, astronauts Frank Borman, Jim Lovell, and Bill Anders had made their final preparations before taking that long ride out to the winning spacecraft. The minimum safe distance from Saturn V at liftoff was 3 miles. The reason was simple. When fully fueled, the rocket contained the explosive power of an atomic bomb. As the clock counted down, the astronauts and all of us in launch control went through the pre-flight checks, our hands on the controls of the most powerful, most complex machine ever built. It had over 2 million separate systems, and to bring these men back alive, everything had to work perfectly. Each individual system had been tested, but what we didn't know was how they would perform when all 2 million began to work together. That moment would come when the countdown clock reached 0. If a maneuvering thruster failed, if communications broke down, if navigation was off by 1 degree, if any piece of the miles of wiring, circuits, relays, or valves was defective, Frank Borman, Jim Lovell, and Bill Anders would pay with their lives. As they sat, waiting for launch on that chill December morning, these 3 astronauts were back to what they had always been, test pilots. You are now in the final minutes before the launch of Apollo 8, right here where it actually happened. Mankind is about to leave his planet behind and journey to another. It is one of those rare moments when history is not being made, destiny is being embraced.
minutes. 3, 2, 1, mark.
Apollo 8 successfully orbited the moon, and the astronauts returned safely to the Earth. I know. I'm Jim Lovell, and I was one of the crew of this spacecraft, Apollo 8. We were the first men to see the surface of the moon from just a few miles away. but it was the hundreds of thousands of men and women who worked in that team and the millions of people who supported the mission that really made it possible. That way, I guess, we all went to the moon. Now, on the other side of those doors, you'll find an actual Saturn V moon rocket. It's still the most powerful, the most complex machine ever built. And I guess it's the only one that can take you to another planet. I actually got to fly one on a second flight to the moon called Apollo 13. But that's another story.
Now this is the Saturn V talking about in the video. The largest machine ever made by man. 3-stage rocket. Got us to the moon. See the stage 1 connected to stage 2. All these stages were non-recoverable. And on down is stage 3. And this is the 3rd stage. So there it is, the Saturn V. This is the service module. Nose cone.
Than in the creation of the International Space Station, a worldwide collaborative effort that is turning our planet into a true global neighborhood. The International Space Station represents a future that lies before you, right here, right now. This is Kennedy Space Center's Space Station Processing Facility, where every piece of the International Space Station launched by the United States will undergo final preparations for the journey into Earth orbit. Like Columbus preparing to set sail for a new world, we now stand on the brink of a bold new era of exploration and discovery. Station hardware and technical systems are shipped here from all over the world. It's our job to perform the detailed tests and inspections that verify each part will function properly in space, and that all pieces fit together correctly to assure a status of launch readiness. In order to ensure the safety of the crew and the success of future missions, each and every component and system must function perfectly on the processing floor before it is launched into space. The processing area before you is vital to the construction of the space station. This area serves as a clean room environment, which prevents contaminants from negatively affecting the sensitive experiments aboard the space station. That's why admittance to the floor is highly restricted. Only essential personnel are permitted on the processing floor. In addition, engineers, technicians, and scientists working within the roped areas or on the stands must wear what are affectionately referred to as bunny suits, the same sterilized garments worn in hospital operating rooms. The space station's major elements arrive via barge, air, and truck, and are stored in sterile containers to avoid bringing any contaminants into the processing area. Once inside the facility, each element is transported aboard an air-bearing pallet, a moving cushion of air that protects the delicate cargo. During and after the space station's actual construction phase, scientists will fine-tune their experiments and fit them into space station racks. The facility will also be used to ready supplies and equipment for shipment to the international crew of astronauts living aboard the station. The creation of the International Space Station is an unparalleled milestone in the histories of both the United States space program and the world. Nations are putting aside cultural and ideological differences to unite as one planet. And with efforts such as the International Space Station to fuel our dreams and ambitions, our universe is certain to grow smaller. The International Space Station will offer an unprecedented opportunity for researchers to gain new knowledge, which will benefit our lives here on Earth. The history of our planet is being made right before your eyes. The dream of one day living in space is coming alive, step by step, piece by piece, here at Kennedy Space Center.
And this assembled and packed up for shipment back to Italy where it was built. When they arrive in Turin, they will be reinforced. They'll become debris shields like those on Tranquility. Debris shields will be an article now, and they did become a part of our space station. So on this time, which we won't come back like we did the first time. We'll become a permanent storage here on the space station. Tranquility node for the cupola, and you see the bar from the building. Cupola is an observatory now, and there is a better way to see outside. Next year, for the first time, we're going to take something from Russia on the shuttle. Russia this year, early Galactic Research Project, Arno and Raphael. They're multi-purpose logistics models. You might think of them as 10-ton suitcases. They're designed to ride inside the elevated orbit, carrying pressurized equipment goes on the inside the space station.
Another day working on the space station. All the components of the space station lifted by the U.S. shuttle come through this room.